Good morning, everyone. Good morning, bright and early, of course. Hope everyone's got a good head after an enjoyable evening last night. Hands up if you don't have a good head. Well done, excellent. Right, so we will move on this morning with our first seminar. So this is the Hopkins Baldwin seminar, which has been put in place to honour two of our more very, very inspiring past presidents of the ISCVE, whose photographs you can see right here, who are no longer with us, but have been such an influence on exactly what we have in front of us today. So that's what this session honours, and I'm going to introduce Dr. Brian Shannan from the University of Edinburgh, who's going to talk to us about inclusive education environments and the hearing ability within them. We often congratulate ourselves about the rapid advancements of technology, but if we don't bring everyone with us, have we really advanced? No least at the educational level, which of course is so seminal to everyone's life and to the life of the world that we live in. So I won't dive deeper. I'll let Brian explain what he's going to talk about, and I shall let Brian start now.
Morning. Can everybody hear me okay? Perfect. Okay, so I am Brian Shannan. I work at the Scottish Sensory Centre. I think it's useful for me to kind of just explain my background a little, as I probably approach things slightly differently to many people that might attend a conference such as this. So I have worked within the university as a researcher, as somebody that has taught audiology to postgraduate students within the university sector. I've also worked both in a clinical and education setting, working with families who have discovered that their young child is deaf or hard of hearing. I have also been responsible for designing building access for hard of hearing individuals, having designed a whole range of schools and other community buildings. And at the heart of the approach is actually to include the people that wear the hearing aids, those with the lived experience, at the heart of the design. We wouldn't design any building or project without considering the people that would use that building and project, because otherwise you can just consume a lot of resources and not necessarily have a positive outcome. So I'm going to talk through some of the work that we've recently been doing at the university within this field. So, if you ask people what technology should be installed for people that wear hearing aids, the answer that most people would give would be a hearing loop. I will argue in this presentation that the technology and the lives and experiences of people that wear hearing aids have been transformed in recent years, and that the technology, such as a hearing loop or an Auracast system, although can be beneficial in certain situations, does not provide the opportunities that hearing aid users require in a modern society. I will look at 4 different landmarks that have made significant changes in the field. first, and although this is jumping back in a little bit in time, is to look at the change in the hearing aids that people are wearing. Because the technology that we are installing and the technology that people are wearing, there is a mismatch. Secondly, to understand the experience that somebody with hearing aids, the experience that they encounter, we need to look at how young people engage and become hearing aid users. We also have to look at the changes that have happened within society that have not only impacted our lives, but also the lives of people that wear hearing aids. And finally, post-pandemic, all our work and educational experiences have been transformed, and therefore we need to look at solutions that support that changing environment. So, when hearing loops were introduced, the hearing aid technology that was available through the National Health Service were linear or analogue hearing aids. That meant that whatever sound went into the hearing aid was the sound that you got out. It was a rather crude listening experience. The hearing aids themselves were rather large, and that meant that they used quite powerful batteries, 13s or 675 batteries. That meant those batteries could cope with running a hearing loop system. I'm not sure if you're aware, but although different hearing aid manufacturers will make different hearing aids, they all get their component, the T component part, from the same source. That component within the hearing aid requires a great deal of power. Hence, you need to have a larger battery. With the introduction of non-linear or digital hearing aids became much more sophisticated. The hearing system is non-linear. Without turning into a audiology lecture, which none of you would want at this time in the morning, the little sensory cells in the ear will respond to sound in a different way. So if you put a very quiet sound into the ear, they will act as the human amplifier and boost that signal. Where if you put a very intense sound into the ear, they will provide minimal amplification. And so a digital hearing aid really replicates how the ear works and therefore gives the hearing aid user an experience that's much more familiar to them. It's a much more natural sound. The problem is that, one of the significant changes is the move, therefore, to much smaller hearing aids. Hearing aids have reduced in size quite considerably. You get now a choice of colours, etc. However, you cannot run that generic T component on a hearing aid with a smaller, such as 312 battery. If you've got a smaller aid, you've got a smaller battery, and therefore you have an issue around making that device accessible. The second factor is that things like rechargeable hearing aids can interfere with that T position within a hearing aid and therefore cause additional issues around interference. Therefore, although the move to digital hearing aids happened a number of years ago, the technology that we looked to put into rooms didn't seem to acknowledge that change. Around about 80% or less of hearing aids now have a T-position capacity. And I don't know what it is like in England, but in Scotland, many of the audiology departments will not activate a T-position unless requested to do so. And therefore, the percentage of hearing aids that have a T-position is an unknown. However, we can say with a relative confidence that it is no longer a universal provision. The second significant change is the move to is the introduction of newborn screening. So newborn screening identifies deafness in children within a matter of weeks, and those children will generally be fitted with a digital hearing aid, and therefore their brain at the earliest opportunity is being stimulated by sound, and that's a sound that they have become familiar with. They expect clarity. They expect to have a good signal. Many of them within an education system will be using a remote microphone system where, like this transmitter here, the person will be wearing a transmitter and it will speak directly to the hearing aid user. So those young people, because newborn screening happens about 20 years ago, those young people are now coming into an education system and expecting the same level of quality that they experienced in school. They're no longer willing to accept a poorer listening experience. This then presents challenges to employers and to the university sector. The next change is much more one associated with sociology, in that we moved in the post-war period to what was called a Fordist society. In a Fordist model, mass production was at the core of provision. Therefore, the welfare state, the NHS, were models where we provided something to the person. Their ability to influence or make choices on that were limited. Through the 70s and 80s, society changed to one where people expected to participate and have a say over the services that were going to be provided. And this is true within the field of audiology, where people get a choice around types of hearing aids, etc. Within an education and employment situation, we are now in a situation where people expect to have a say and have their voice heard. And therefore, it's important that when we are delivering something as important as communication, that there is a level of engagement. The pandemic changed many things, not only how people work through hybrid type employment, home, in the office. Similarly, in education settings, systems became much more hybrid. This means that we moved from a building with 4 walls to online platforms such as Teams and Zoom. In fact, Teams and Zoom became the new room. It wasn't a physical room, but it's a room where people engage and learn. And therefore, when designing access, we need to consider how people with hearing aids can actively participate in two-way communication. And therefore, when we look at hearing loops, or its predecessor, the Auracast system, what we have are one-way communication system models. The hearing loop is a one-way communication model. Auracast is a one-way communication model. Sorry for that. However, as I said, we live in a world where we want two-way communication, and two-way communication is possible. So, as I said, I've worked in building design for a long time, but I'm going to focus on some of the work that we've been recently doing at the University of Edinburgh. So the University of Edinburgh have a disabled staff group. I met with the disabled staff group very early on, and we looked and demonstrated a range of equipment. Some of the project managers that run the management of the building services wanted to test different systems with the hearing aid users, and the type of equipment, such as the system I'm using now, were the ones that the staff group favoured. This then led to us receiving funding to set up a pilot room. The pilot room is in the Bio Quarter, which is the medical school just near the Royal Infirmary in Edinburgh. Within that, we installed technology associated with the Phonak Roger platform. We put a range of room technologies, which we will look at, a Roger base station, wall pilot, and other type technologies into the building. We then worked with the hearing aid users. They would come and say, oh, by the way, I can overhear my own voice in this. And I would go and resolve a problem. And we worked our way through each issue until we got to a model that worked. Through those conversations, the disabled staff group made clear that they had 2 major complaints. The first was that they wanted to attend a meeting or a lecture and access that without having to identify themselves. This is the same issue that young people have in schools. They don't want to hand over equipment. They don't want to look like they're different. So we solved this through a thing called AutoConnect, which we will explain later. But their second complaint was they wanted a change in culture. They wanted people who run meetings to be much more inclusive, rather than stand at the start of an event and say, just as I did, can everybody hear me? Does anyone need this special equipment? They don't want that. They want to be a part of a community, included without being singled out. So, building on that success, we rolled out this model, which is a lot more sophisticated than the traditional setup. So rather than having a single room solution, I designed specific solutions for each learning environment. And that's at the heart of this. We can make bespoke systems rather than I'll tick a box, I've included a loop, I've included an Auracast system. So we set up within the building, the engineering building, there are 7 meeting rooms. There's 7 small meeting rooms. So within that, we incorporated a transmitter that's normally used by deaf and hard of hearing people as the main microphone for the meeting. So we didn't have a microphone system for hearing and a microphone system for hearing aid users. We had a single microphone. The benefits of such an approach is that if there's a fault with the microphone, everyone is affected. Everyone can resolve the problem. If you have 2 systems, somebody with the hearing aid could be having a fault, not be aware of this, and therefore they have an issue and they don't want to identify themselves. The second system was for a larger meeting room. The larger meeting room almost mirrored our pilot room. Namely, we had a Sennheiser omnidirectional microphone in the ceiling, and that became the meeting microphone. And I'll go into that in a little bit. We then had systems for smaller teaching spaces, and we had systems for larger teaching spaces. So here is a picture from one of our small Teams meeting rooms. The picture on I'm terrible with my left and right. When I used to put headphones on children to test their hearing, I would always have to go left, they're right. So, but it's on my left. So on the left, you will see on the wall is a Logitech Tap 5e screen system. So when we were designing this project, I worked with the project manager on making sure we could incorporate the technology into the design so that it was quite seamless. So on the desk, there's a little cradle unit that has the Roger touchscreen. That is the microphone that's for the meeting. So that microphone sits in the centre of the desk, and it will pick up everybody who is talking in the room. The second picture, which is the little neck loop, which is this, which I'm using for our subtitles today, is attached to the end of the Logitech system. That is the microphone for the meeting. The third picture, and I'm not going to win any awards for my photography, but the third picture, the little thing with the green light on it, that is a little media hub, which is our audio system. And as you can see, it's hidden behind the screen. And then the little box with a tick on it is called a wall pilot. The wall pilot allows us to auto-connect the hearing aid user to the system. The wall pilot is in the ceiling. So what happens is that the hearing aid user enters the room. They automatically connect themselves to the room. The meeting starts, the way that it's been set up means that the hearing aid user does not hear their own voice directly through the microphone, because that was one of their complaints. So we devised a system that allowed them to hear in a different way. So I go back to being able to sit and design a project with a team. In the larger meeting space, the room is it's about the size of this room, and tables are set up in a rectangle. So rather than the small Logitech screen, we have a significantly larger Logitech screen. On the top of the Logitech screen is a rally bar. That's got the sound that will play to everybody else within the meeting. In the larger meeting room, we have installed a thing called a base station, but that also sits behind the screen, and it picks up the audio. So within the meeting, the hearing aid user is getting the sound broadcast directly to their hearing aids, and everybody else is getting the sound through the rally bar. Again, the wall pilot is situated in the ceiling, so they just need to walk through the door and they're connected to the meeting. Here is one of the small teaching spaces. In many universities, they have an audio unit at the front, the teacher's lectern area. And what you'll see is in the second photograph, the base station is situated, it's got the little aerial on it and a knob on the front. That's the Roger base station. It's a very small device, and it's integrated here within the AV rack. Remarkably, it just plugs in through a 13-amp socket, and it's got a XLR cable that takes all the audio and then broadcasts that to the hearing aid user. Again, the wall pilot is the method that they will walk in to the room. For this project, we put it on the ceiling. However, going forward, we are looking to use the room booking system because it already has a power source, and almost use that power source to stick the wall pilot so that it's used as soon as you walk in the door. So that's the way we're going to do it going forward. Within this project, we have rooms that are far larger, and so you get a little device called a repeater, and a repeater just extends the range of the network. And the network is the important part here, because in a network, you want to contain the sound within the room. For anyone that's used hearing loops, I used to test a hearing loop, or I was asked to test a hearing loop in a public building in one of the large local authorities in Scotland. I was in reception. The way I test a hearing loop is I've got a little hearing aid with a T-position on it, and I was standing at reception, and I was listening to a meeting which I don't think I should have been listening to. It was the only time I've been in a meeting where I was actually nearly engaged. And I could hear somebody talking, but I have no idea where that was coming from. It's not secure. Auracast promotes itself as saying, you know, we can cover an area of 160 plus meters. That's not great in any setting, unless it's a large area, because you want to contain the network within a room. So with the repeater facility, you can control how far or not your network works. So, why does this approach work? So rather than just rushing ahead and choosing a system from a shelf, it engaged with the people that used the system. It allows two-way communication. From a university point of view, it allows easy installation. It's basically plugs. It's portable and flexible. You can move the system between different rooms if required. Many universities now run professional learning models and are looking for that type of flexibility. And as I said, it's a system that can be scaled because you can build or reduce your network depending on the location. So, the challenges are that we need to move away from a fixed design model. Deaf, hard of hearing equals loop, Auracast. We need to move to one where we design access depending upon what the purpose of the room is for. If it's for meetings, if it's for teaching, what's the purpose? It's important, rather than just taking something from a shelf, is that you work with the AV company or the project manager to ensure that we've got the right setup. As I said, the people at the heart of this are the hearing aid users, so they have helped ensure that we've got that auto connect feature, but they've also been involved in looking at how we design the posters and other materials to ensure that people are using the system and can access the system appropriately. So, in summary, the systems that are available are currently looking at one-way communication rather than a much more interactive model. Auracast is certainly going to be an improvement. However, it still just replicates the same philosophy as before. People that are wearing hearing aids are far, far more sophisticated. You know, in Scotland, we don't pay tuition fees. Don't know where we get the money from, but I don't know. That's why we're all broke. But in England, I believe students are paying thousands of pounds, and you hear of the amount of debt they are in. If you're a hearing aid user, and I've got that amount of debt, I'd expect my building to meet the requirements that I was used to within an education setting. And I think the more that we work with the people that use the system, the better the outcomes will be. Within the setup, and I forgot to mention this, but today we've been using the subtitle systems. Within each of our learning environments, we have speech to text through that system using something like this. Therefore, you can incorporate it within specific software, or you can use it within PowerPoint. But it allows the other area, which is a big area of AI and speech to text. This technology provides that. You don't need to have two separate solutions. You can incorporate everything into a single solution. So, thank you so much for taking the time to listen to me today. My contact details are there, and I'm happy to discuss anything that we've been involved in.
Thank you very much. We still have about 7 minutes left if you're happy to take a few questions.
Of course.
Jamie was the first one up, I could see. Well, maybe, sorry, maybe I wasn't looking. Hang on, Jamie. I know you don't think you need a microphone, but you do need a microphone.
Sorry, 10-4 a Right. This may be a silly question, but what is the Roger system?
That's a very good question. So the Roger system is a kind of is made by the company Phonak, and it's a platform that has a range of microphones such as this, or it has a range of devices that allows rooms to be accessible. So the technology, the Roger's the platform, Phonak are the manufacturer, but the devices can be something like this, which is an individual microphone. However, universities don't want to have to rip out their whole system and start using different microphones, because you can't use that if you're doing recording lectures. Therefore, with the base station, that little device that I showed the photograph of, that will take every microphone and broadcast straight to the hearing aid user. Therefore,
Is that
you don't.
via Bluetooth or something?
No, it's through a digital 2.4 gigahertz platform, so it's not Bluetooth, and the sound quality is remarkable based on the people that provided.
The hearing aids must have already had the receivers.
Yes.
So you can activate most of out of all the staff group, something like 95% of the people had a hearing aid that we could activate their little receiver in, because those hearing aids, they're already inside the head.
Right.
Most people don't know that.
Well, I didn't.
The second thing is this little device, which I'm using for speech to text, that has a little neck loop with it. If you are not got that device, you could put that, wear it under your clothes, and you access the system in the same way. So within each of the rooms, we have 2 of these for hearing aid users that don't have the system, and that also makes it a easily managed system, because you're not having to go to somewhere to get something.
Yeah.
Again, that kind of shame is the word that
Drawing attention to yourself.
So,
question.
is there a website we can go and find out about?
So I've put that on I've given a link to our website, so I'll give you that.
Okay,
I'll write that down for you later.
Thank you.
Okay.
So we can do the question at the back. Thanks, Jamie. And then the next one's over there. Yeah.
Hello. Can you hear me?
I can, yes.
Okay, so maybe slightly more challenging questions this time.
That's it.
Obviously, the majority of what we've just done today has been direct from you to us. So at this point, up until this point, we don't really need the two-way communication. But now we're provided with a microphone, so that's great. I can do this. We're in a position here where I echo exactly what you've just said in terms of ensuring we make sure we tailor a solution to the application, et cetera, et cetera. But what we've seen today really is a bit of an assassination of both Loop and Auracast technologies, in the sense that actually that fits a lot of environments and applications with the right supporting tools. I also like to contest a little bit of incorrect information and misleading facts based around a telecoil, in which actually I've got one in my hand here that just runs off the mic bias. That wasn't the driver for it disappearing out of hearing aids. It's probably more to do with the bulk and size and all the rest of it. So just wanted to put some of those things out for you. If you want to respond to that, you can.
Yeah, absolutely. So one-way communication is absolutely the heart of Auracast and Loops.
Absolutely.
That's uncontested. Yeah. My argument is that our society has changed and requires two-way communication.
Yeah,
so
absolutely.
You need to have a solution that requires to provide that.
Yeah, where that's necessary, yeah?
My argument would be that, similar to the new engineering building, that we are building platforms for Teams and Zoom because that's part of education and part of the workplace now.
Yeah,
So that's why you need to incorporate two-way communication.
Yeah, you build the solution to support that.
Yeah.
That doesn't mean to say you have to buy a Roger system, though.
No, I'm not saying that.
So we had one at the back corner. Was there any other questions? Yep.
As a super presentation, thanks so much. It's great to see good examples of how to apply available technology for a given application or study. So that's good, great to see that. My question was, in situations where you have a mix of deaf or hard of hearing occupants in a space with unimpaired hearing occupants, both sharing and using the same space equally, as you said, in terms of a two-way communication application. Have you considered, and this is with my acoustic engineer's hat on, did you consider the room acoustic performance of the spaces under these dual user applications in terms of things like, the speech transmission index performance of the space or the reverberation time performance? And if so, how did you go about doing that? Thank you.
That's a fantastic question. Now, as somebody that spent a lot of their time arguing that we should be measuring the C50 index as well as the RT60 index within a room, and having been involved in a variety of building projects, I'm not sure what it's like in England, but I can only talk about Scotland. Generally, the architects and the people supplying the acoustic treatment for rooms will go with a standard to try to apply to Building Bulletin 93 standards. However, at no point after the design stage does somebody come back and measure how effective have they reached that target. Yeah? So within each of the spaces, you make the assumption that the appropriate acoustic standards have been met, but with a large pinch of salt applied. And it's very interesting, increasingly, and this is one of the complaints from a lot of the audio-visual installers, is they're doing away with false ceilings and putting in a lot of the floating acoustic tiles, and people are finding it difficult to locate speakers and other things within the spaces. So within each of the rooms, we installed the technology assuming the standards would be met, but knowing that that's more than likely not the case. And as I said, and you will know this, at times you can be in certain rooms and you think, I think they've maybe put too much absorption into this room and therefore compromised the C50 properties, which are the heart of making speech clear, obviously.
That's great. Thank you very much.
Thanks.
Thank you. Question at the front here.
I have had experience of a number of different assisted listening systems. When it comes to devices like the directional ceiling mics, the technology is superb. Very impressed by them. Just on my own personal evaluation, it still is picking up early room reflections. It's picking up background noise. It still doesn't work anywhere near as good as a microphone that is close to the talker. Yeah, and my fear would be that, for standardising an inclusive system in there, that it still doesn't quite hit the level of intelligibility that, say, a profoundly deaf user would need. And the second point, if I can throw it in, the speech-to-text is, again, superb, but it distracts. I either have to look at the text or I look at the talker. If I look at the talker, it's not coincident, and the parsing and the timing and the corrections of it means that it might be useful as a summary afterward, but it's actually not so good as a real-time communication aid. So Sorry, two things there. But
No. Now, on the first point, what you described is what the members of the disabled staff group described. So that's why when we created the small teaching spaces, okay, we used an omnidirectional microphone, where they did not hear their own voice. They were hearing the system. It's a complicated way of doing it, but we created different types of networks so that the hearing aid user was getting the sound back in a different way. And that worked well according to the hearing aid users. In the bigger rooms, you're absolutely right with the omnidirectional. Now, the way that we worked around that was using the hearing aid app within the system to change, so to allow the hearing aid user to change their hearing aid balance so that they could improve the clarity. But yes, having an individual microphone is preferable. However, the desire from the group was to have a system where they were not singled out. And on the speech-to-text part, totally understand. There's some people it will work, and for some people it will not. The point is that for many people within a university sector, students and others have got individual devices. So you could run the system on an individual computer. However, there's a whole range of people within a university setting that might not actually have hearing issues, but they might have English as a second language, etc., and so they can benefit from the speech-to-text. And because of AI, that speech-to-text is far better than it was even 5 years ago. But yeah, thank you. When you got a Scottish accent. Exactly. Can't help that.
So, thank you very much. We are 3 minutes over time, so unless there's any more pressing questions, I will draw to a close and hope that, Brian, are you sticking around for the most of the day?
For a little bit this morning.
For a little bit this morning.
About lunchtime.
There you go. There's your answer. Good stuff. So let's thank Brian for that fantastic talk. Thank you.